Welcome everyone to Zahid's data mining channel once again. In my previous videos, I have demonstrated how to use Weka as a software tool to use existing decision trees and forest algorithms to apply them on a dataset and thereby build a decision forest to discover knowledge from the dataset. So in this video, I will demonstrate or discuss the challenges in doing that and how to overcome the challenges, how to discover knowledge from an existing dataset better and easier. Now this is Weka, you can see on the screen, and I have opened a dataset called diabetes, and you can see there are various variables there. And then, as I demonstrated before, I can choose any existing decision forest algorithms, for example random forest, and build a number of decision trees in the forest, and then try to discover knowledge from this. So when we do that, we have chosen random forest and we run to actually discover knowledge from the random forest. We see that we can find the accuracies, etc., but we cannot see the trees there, but that we can overcome by using one of our algorithm, SysFor, and we can choose the number of trees and so on and so forth. Say for example, by default we are building 60 trees, and if we build those trees, then we can see the trees have been built immediately. So this is tree 1, and as I have demonstrated before, through the decision trees you can see the logic rules there. It says if plus is plus value, if you remember that this is one of the variables that, of the data set, and it suggests that if plus is less than 166.5, mass is less than 26.3, then the patients are generally tested negative, they are not diabetic, and there are 159 such cases, only 9 are actually diabetic. So this is how we can see the rules there. But the problem for knowledge discovery is there are so many rules, because we have built 60 trees. We could build 100 trees, few hundred trees, but from those decision trees there are so many rules that it becomes very difficult for a data analyst or an end user to find out important rules, interesting rules. That is why today I will demonstrate a new software that we have uploaded called ForEx++, and how to use that in order to discover more useful rules first. Now, in order to use ForEx++, you have to choose that software first, and you need to install the software as I demonstrated before. So for installing ForEx++, you need to go to the tools of your standard Weka, then go to package manager, and then when the package manager screen appears, then you have to go to the available radio button, click the available radio button, and you may actually then see all the available packages there and search for ForEx++, and you will find ForEx++. Then you have to choose and install. So that will make ForEx++ installed, and once it is installed you may need to restart Weka. Once you restart Weka, then if you go to the package manager again, then you will see that ForEx++ is installed already. For example, here now when I click the installed radio button, I can see ForEx++ there. So ForEx++ has been installed that way. Now you have to open the Explorer again, and of course you have to open your desired dataset. In this case I will be opening the diabetes dataset again. Now if I want to open ForEx++, I will go to classify and then choose a classifier. It's not a tree, it's a meta classifier, and because you have installed ForEx++, you will see ForEx++ in the list. You choose that, then ForEx++ is actually being used now. Now when you click on ForEx++, you will see various parameters that you can set for ForEx++. The ForEx++ is a algorithm that we published recently that can use theoretically any existing decision forest algorithms to build a number of decision trees. In my previous demonstration I showed it was a problematic thing when you have 60, 70, 100 trees, so many rules. And the trees can be built using existing algorithms like SysFor, Forest PA, random forest, bagging, boosting, etc. Now ForEx++, once these trees are built using an existing algorithm, can actually pick best rules for you. So the problem that we faced before, so many rules, is kind of handled here. So here ForEx++ in our implementation in Weka, you can also choose a classifier. Okay, so by default it says SysFor, but at the moment we have implemented it for SysFor, random forest and forest PA. You can choose any one of them. Let's choose SysFor, and then if we click on it, then this will help you to determine SysFor parameters. For example, number of trees, we had 60. Let's say we now build 5 trees. You don't have to, you can keep it 60 or even keep it 100, but we are just demonstrating that you can actually choose SysFor parameters. Minimum record in leaf, let's say 50. I'm changing some parameters in SysFor. Now in ForEx++, there is a parameter called print classifier false. You can turn it to be true so that you can actually see the trees and leave them true. So it is using both all of the parameters like accuracy, coverage and rule length to choose the best rule sets. Now after that, when you start ForEx++, it finished already, it has done its job. See, I chose 5 trees, it has built those 5 trees. So in SysFor, if you remember, I chose number of trees 5, it built those 5 trees. If I chosen 60 trees, it would build 60 trees. And the problem that we faced before, so many rules. Now if we go up, you will see that it has actually identified only few rules for us that are interesting. So from tested negative class, it has found 7 rules. Each line here is a rule out of these trees, and from tested positive class, it has found 2 interesting rules for us. Now possibly you are thinking what mechanism it actually uses to find out these interesting rules. In order to answer that question, I would request you to go and read our paper ForEx++, and also in my previous video I have explained it briefly. So in that paper you will see the technique that it uses, and it's a very simple approach, it's a very simple technique. All it does is it considers all the rules that have, and it considers their accuracies for both classes, positive class and negative class, and then it checks the average accuracy for all the rules, and it finds out those rules that have accuracy higher than the average accuracy for both classes. So then it gets a subset of rules. Now it does the same thing for support as well. So for every rule there is a different support, number of records belonging to that leaf, that rule. Then it finds out the average of that for both classes and it finds out a subset of rules that have higher than the average support. Similarly, it also considers rule length, and it finds out those rules that have smaller rule length, less if-else, than the average rule length. Now it finds three different sets of rules, right? Rules that have higher than average accuracy, higher than average support, and smaller than average length. Now it intersects these three different sets to find out the real smaller subset of rules that satisfy all these three conditions. When you look at the software, this is what you see there. Use accuracy, that means in order to find out the finer set of rules, do you want to use accuracy? If you say no, false, that means you are not using accuracy as a selection criteria. You are selecting the subset of rules based on only coverage and length, or you can choose any one of them to be false or to be true, and then you can actually run ForEx++ again, and this time you will get a slightly different set of rules. Whatever you choose to do, once you find this set of rules, you can again use an Excel file like this to actually represent the rules there. So plus value less than 166.5, mass less than 26.3, tested negative, and you have the confidence value, coverage value, etc. So you can actually put those rules in lines in one row of the Excel file, and you can see the rules on Excel file as well. And then you can actually use Microsoft Access to query the database to learn actually more about the rules. For example, here you can say the first rule is saying when the plus value is less than 166.5, mass is less than 26.3, then generally the patients are negative, diabetic negative. You can see, okay, what is the other side of the rule if plus value is greater than 166.5? So you can just write an access code, SQL code, select count from diabetes when plus is actually greater than. So when you make a query for this rule, you can see that plus is less than 166.5 and mass is less than 26.3. If you run this query, then you see 159, exactly the same number, right? So 159 records are there. Now we can change this to, instead of plus less than 166.5, plus greater than 166.5, and run this query again, and we can see there is only 8 records there on the other side of the rule. So here, when plus is less than 166.5, there are 159 records, but on the other side there are only 8 records. And we can even go and check that how many of them are actually positive or tested negative. Positive or tested negative. So when we write this bit there additionally, that how many of them are tested negative, because here we can see there are about 159 and minus 9, so 150 negative cases. But if we check the plus value greater than 166.5, and we can see how many of them are tested negative, there are only 3. So on the other side there are only 3 tested negative cases. But if we check how many tested positive cases, then we can actually see that, oh, there are 5 tested positive cases on the other side. So these sort of analysis we can do, and based on this analysis we can then graph. We can graph these numbers, say case 1 when the rule is like this, or so for this first rule, and case 2 when the case 2 is just the opposite of that, and we can see how many records actually belong to those rules. And this way we can also